Hey, good morning, everybody. And I say good morning because we're talking at 3 o'clock in the morning here, and Mr. Ainsworth cannot sleep. So, guess what? I'm doing you guys a favor and making a cool video on Unit 2, Section 5 here in the textbook, Section 5.5. So, that's Chapter 5, Section 5 on what's called standard form. This also includes some vertical and horizontal lines, graphing them, of course. It also includes some transformation from, let's say, another form like slope intercept into standard form. So this is a big lesson here. It goes in multiple parts, starting with graphing a linear function in standard form using multiple methods. First, the intercept method, and then the slope intercept form method. Okay, the method of using zero. So I'm going to show you that one first. We're going to go through it, uh, as slow as possible. Your homework here, obviously in the textbook here, oops, let me bring it back up. There we go. Is from 322 to 326 in your textbook, section 5. The first few pages are the lesson, more examples in the textbook, followed by your homework on page 325 326, and do these following problems here in your spiral, okay, that you guys have. So our first goal is to graph, okay? Is to graph a linear function in this form. It's called standard form, where the variables are on one side and a constant is on the other. Okay, notice that our first equation here is 2x minus 5y equals 10. So that's in the standard form. Notice that a is 2 and b is -5 and c is 10. All right, the variables are on one side and the constants on the other. Whenever that happens, you have something in what's called standard form. Not the slope intercept form that you guys are used to, where y is isolated. So we're going to get into that form here in a minute, but first method here, which is cool method here, is called the intercept method, finding the x and y intercepts for the graph, okay? Where does it intercept the x-axis? It's called the x-intercept, and where does it intersect the y-axis? Called the y-intercept. So how do you find them? Well, we know, all right, that any point on the x-axis, like this point right here, okay, is 2, 0. Any point on the x-axis has a y-coordinate of 0. So to find any x-intercept where the line crosses the x-axis here, this is the x-axis. Up here is called the y-axis. This vertical one here. Any point on the x-axis, the y-coordinate is 0. So what you do is you set y equals 0 and solve for x. Conversely, this point up here, let's say this point, that is 0, 3. And notice that the x-coordinate is 0. So to solve for any y-intercept, you let x equal 0 and solve for y. And that's the method. Okay? So those were just for examples. Those were not the actual x and y intercepts. Those you have to solve for. Okay? So what we're going to do is we're going to take our equation here. So 2x minus 5y equals 10. All right? And what I just said was that you set y equals 0, or basically substitute 0 in for y and then solve for x. Okay, that's how to find the x-intercept. We'll do that here in a minute. All right, so here we go. So 2x minus 5 times 0 equals 10. We got to solve for x. So notice that I just substituted 0 in for y. That's all I did. So when I say let y equal 0, I mean substitute it in and then solve for the other variable. What's cool about this method is that you can do it in your head once you get experienced, because we know that anything times 0 is 0 here. That's 0. So what I have is 2x equals 10. I mean, because 2x minus 0 is just 2x. And then you obviously have to figure out, 2 times what number is 10. And you can do it in your head. It's got to be 5, right? 2 times 5 is 10. Or you could be pragmatic or robotic and, divide by 2. Okay, but you'll still get 5. All right, so you let one variable be 0. All right, in this case, the y be 0. And you solve for the other one. So when is 2x equal to 10? Well, when x equals 5. So it's 5, 0. This is called your x-intercept. Why? Well, it's because it's on the x-axis, okay, at 5, 0. So let's go ahead and graph here. I'm going to rewrite the labels over here a little bit, because 5, 0 is right here at 5. Okay, that's 0, 5, 5, 0. Come on, Ainsworth. It's early in the morning. Okay, like I said, it's 3 o'clock in the morning. I just couldn't sleep. Wasn't feeling too well. So that's the X-Intercept, the method of finding zeros or using zeros, all right? Substitute 0 in for y, solve for x. You always substitute 0 in for one variable and solve for the other one. It's that easy to remember. It's called the intercept method. Okay? Why? Because you're finding intercepts. I just found one, the X-intercept. Now what I do is I substitute 0 for x and solve for the other variable, y. So let me write the equation again. Okay? Now I substitute 0 in for x, so I have 2 times 0 minus 5y equals 10. Well, you know that anything times 0 is 0. So you got to figure out when is negative 5y equal to 10. You know, negative 5 times what number equals 10? Let me rewrite that. Negative 5 times what number equals 10? What would this number have to be to get 10? Well, the answer is negative 2, right? If negative 5 times negative 2 is equal to 10. So otherwise, what you do, let me put the variable back in here. You divide both sides by negative 5 and you get the same result, y equals negative 2. So since x equals 0 here, your y-intercept this time is 0 comma negative 2. And that's called your y-intercept. Now 0, negative 2 happens to be down 2. It happens to be right here. 0 comma negative 2. That's called the y-intercept. Why? Because it's on the y-axis. It's almost too easy, guys. Okay, and then from there, you graph the line. So take out your straight edge here, your ruler, and then connect. Make it a little bit better than that. There we go. Okay, so there you go. Make sure you go right through the points. And that is your first method here. It's called the intercept method because you're just finding intercepts. And I call it the method of zeros because you're using 0. You substitute 0 in for one variable, and then you solve for the other variable. It's that simple. So when you let y equals 0, then you solve for x. When you let x equals 0, you solve for y. You always solve for the other one, right? That makes sense. And then, of course, you write the points as ordered pairs. All right, points are ordered pairs, x comma y. And then you plot. So you plot these babies, you plot the points, plot the intercepts here, okay, and graph the line. Let me highlight that, okay? So you plot the intercepts and graph the line, as I just did. Now that's the first method. That's the easy method. And when you get good at this, you do this in your head, guys. Because substituting 0 into an equation is simple because it zeroes out the term. All right? Because anything times 0 is 0. The other method is called the slope-intercept method. Okay? We convert the equation to slope-intercept form. All right? Let's highlight that. Slope-intercept form, that is y equals m times x plus b, which you're familiar with, and use the slope in the y-intercept to graph the linear function. So we're going to transform from standard to slope-intercept because graphing from there is a piece of cake. And all you do is isolate y. That's the key. All right? That's the key idea. So let's do that. Now to isolate y here and to solve for y or isolate y, however you want to say it, you have to add the opposite first. All right, so you get the opposite of 2x is negative 2x. So add the opposite first. There we go. These cancel. Bring down your y variable. And keep in mind, notice that I separated the sides of the equation here. Just use your highlighter and go right through the equal sign. And notice that in red here, I subtracted 2x on both sides because 2x minus 2x is 0. All right, I'll just put a 0 right there. Opposites always combine to 0. And then on the left-hand side of the equation here, I have a minus 5y, so it indicates that it's negative. So when you're subtracting it, it becomes negative. So you got negative 5y equals, Now you can write this two ways. You can write it as 10 minus 2x, or since the mx term comes first, right, this comes first in the slope-intercept form, write it as negative 2x plus 10. So negative 2x and then plus the 10, because I'm adding a negative 2x to both sides. All right, I added the opposite. Add the opposite. OPP is opposite to both sides in red. So when I say add the opposite, I'm taking a negative 2x plus the 10. So write it in the form that you want it to be in. So instead of writing it 10 minus 2x, write it as negative 2x plus 10. Now divide now, because it's negative 5 times y. So divide all terms by negative 5. Notice I said all terms by negative 5. And what do you get? Well, you get y on the left-hand side, because these cancel to 1, right? Negative 5 divided by negative 5 is 1, and 1y is y. Here, notice that I have a double negative here, so these cancel. And you get 2/5 x, there's your slope, 2/5 x, there's your slope right there. And then 10 divided by negative 5 is negative 2, so I'm going to write it as minus 2. You can write it as plus negative 2 as well if you want. Okay, and that's just your y-intercept. Okay, b equals negative 2. So b is negative 2, or 0, negative 2. The slope, monte, okay, the slope is 2/5. And notice that I have rise over run here, so that means up 2, all right, right 5. Why? Because 2 is positive, so you go up. 5 is positive, so you go right from the y-intercept. So to use this method of plotting the graph versus a set of points using an XY table here, you plot the y-intercept first. Okay, let's highlight that. So you plot the y-intercept first, and that's right here at 0, negative 2. So I'm going to plot right here. Okay, you plot that first, right there. And then secondly, you use the slope. So step 1, plot the y-intercept. Okay, step 2, use the slope. Okay, so put your pencil on the y-intercept. And what we're going to do is we're going to rise and run a little bit. We're going to go up 2, right 5. So up 2, and then right 5. Okay, from this y-intercept. So we count. So get your eyes right here at negative 2. You always start at the y-intercept. Always start at the y-intercept when using the slope. When using the slope. Okay, so here, get your pencil at negative 2 here on the y-axis. And we're going to go up 2, right 5. So up 1, 2. Notice that, look at the red dots I'm counting. So in fact, I'm going to use an arrow here. I'm going to go up 2, put a 2 here, and I'm going to count right 5. 1, 2, 3, 4, 5. Draw an arrow. Okay, this represents your slope. And then plot that point right there, which is right here. Guess what? That's your x-intercept. And that makes sense because up here, we plotted a point at 5, 0. So if you look here on the graph, what we did earlier here kind of makes sense. Now I started here at the y-intercept. Look at the slope. Go up 2 and then right 5. There's your slope. That staircase effect right here. Okay, and then what you do is you take your straight edge out and you connect your points. You got 2 points here. So then step 3 would be to graph your line. And so you're going to be using the slope. You start at the y-intercept, as I said earlier. Okay, so let me go back to big view here. So you always start at the y-intercept, and then you use rise and run. You go up 2, right 5 from there, up 2, right 5, and then you graph your line. And use a ruler, use a straight edge, okay, when graphing. So use a ruler when graphing so you can, make a nice line. Okay? All right, so there we go. That's all you do. So you isolate y, you get your slope-intercept form, you identify the slope and the y-intercept. Okay, I did that. I wrote them down. The coefficient of x is always your slope. That's your m value. M for monter, meaning to climb, as in a hill, which has slope. Okay, it comes from the French word monter. And then using the definition of slope, rise over run, we know that 2 is positive, so it's an up movement, and 5 is positive, so it's a right movement. And starting from the y-intercept here, guys, you go up to right 5 and then draw your line. Okay, 2 points determine a line. 2 points determine, all right, a line, and that is why this method is so cool, is because once you plot the y-intercept, that's 1 point. Well, you need another point so you can line up your ruler. All right, you should have learned that or figured that out like in grade school. And then you simply line up the 2 points, the y-intercept and the other point that you find. And it's not always on the x-axis, but this happens to be. And then you simply graph your line. Okay, so the first method, a really cool method called the intercept method, finds the x and y intercepts, and you just connect them with your ruler wherever they may be. And then the second method, well, you get the same line. You get the y-intercept here. Well, after you solve for y here and get it in slope-intercept form, you plot the y-intercept first because now you know it. It's right here in the form, the slope-intercept form. And then using the slope, you go rise and run from that point to get a second point, and then you simply draw your line. Okay, and we'll be practicing both right here. Okay, speaking of that, let's practice, okay? On this one here, I want you to, since this is a video here, I want you to pause and play now. All right, at your own speed, okay? At your own speed, which means this. Okay, I want you to pause the video now and go through this entire thing, and when you're done, press play and review it, and make sure you're correct. Okay, pause the video and go for it. Okay, I'm assuming you already handled this, so let's check your work. Okay, so let's take 3x plus 4y equals 12. Let's substitute 0 in for y, and then solve for x. So 3x plus 4 times 0 equals 12. That cancels. So you get 3x equals 12, and since 3 times 4 is 12, x equals 4. So that tells me that I have 4, 0 as my x-intercept. Okay, so I'm going to plot that. 4, 0 happens to be right here. Now I let x equal 0. So I always write down the equation so that it helps me focus here. So I substitute 0 in here. So 3 times 0 plus 4y equals 12. That cancels out. And I get 4y equals 12, which means y has to be 3. 4 times 3 is usually 12. So I get 0, 3 as my y-intercept. So let me plot that point. 0, 3 is up 3. You know, at 3 here, and this one's at 4. And then what you do is you just simply draw your line. All right, line them up. Boom, right there. There's your line. So you plot your intercepts. This is your y-intercept. And this is your x-intercept. All right, label your lines. Okay. Now the second method, we're going to graph the same line here. However, we're going to use the slope-intercept form method. So we're going to transform from standard to slope-intercept by isolating y. Okay, remember that was our technique. All right, so pause the video right now and go for it. Okay, I said pause the video. Try it first. Don't just listen and copy, okay? Make this lesson interactive here. Okay, here we go. Let's check your work. I'm going to isolate y. We're going to add the opposite first, okay, because 3x is positive. So you're going to add the opposite, which is a negative 3x here, to both sides. Okay, there's the left side and right side. I did it to both sides. The opposites cancel to 0. Bring down your positive 4y. And write this as negative 3x plus 12. Remember, I just said add the opposite. So add these two things, negative 3x plus 12. And write the x term first. If you wrote it as 12 minus 3x, that's okay. But remember, you want the x term come first. This should be comes first in the equation. Divide everything by 4. All right, and you get y is equal to negative 3/4 x. There's your slope, by the way. So I know my slope's negative 3/4. 12 divided by 4 is 3. And there's my y-intercept at 0, 3. So I'm going to plot the y-intercept first at 0, 3. Always start here. Okay, and then now the slope's negative 3/4. So since the rise is negative, this means down 3, and 4 is positive, so that means right 4. So down 3, right 4. That's what the slope is telling me. So put your pencil right here at 3. We count down 3. 1, 2, 3. Down arrow. Right 4. 1, 2, 3, 4. And then you plot a point, which is right here. So we got 2 points, and what we do is we get our straight edge out, and then we draw the line right there. And then if you compare the two, holy cow, look at that. They're the same line. It has the same slope. Look at that. So the one up top, even though I didn't use the slope, you can see it. Down 3, right 4. You can see the slope in there as negative 3/4. Here, I used the slope because remember, this was a different method, right? So here I used the slope instead of the two intercepts because I didn't know the x-intercept in this case. I only knew the y-intercept at 0, 3. So remember, you always start at the y-intercept here, and then, so this is step 1, and then step 2, use the slope. Okay, guys? And that's how it's done. Now, the second goal in the lesson is to transform any equation into standard form, using integers only for a, b, and c. And notice that here, the coefficient of x, which is a, is not an integer. It's a fraction. Okay, so when I say using integers, okay, I'm saying no fractions. Okay, no fractions, using integers only. So the key idea on this one is we got to learn how to clear the fractions. Okay, so how in the world do you do that? All right, and what does that mean? And then get the variables on one side and the constant on the other. So notice x and y are on the left, and the constant right here is on the right, and that's called a constant. Not just because it starts with C, but that's usually just a constant. You'll see that happen in a minute. Okay, so we're going to go from slope-intercept form here, slope-intercept, because that's what this form is in right now, all right, to standard. So the way we do that first is by clearing your fractions. So whatever the denominator is, in this case it's 7, okay, I'm going to multiply everything by 7. Multiply both sides by 7. Okay, so I take, remember this is left side here on the left and then right side. So multiply both sides by 7 using the denominator. Okay, so you look at the denominator and say, hey, it's 7. So to clear the fractions, you multiply both sides by 7. So you take 7 times y on the left. Let me do that better colors here. So 7 times y. So notice I just brought the equal sign down. So I multiply the left side by 7, and then you multiply the right side by 7. And just put that right side in parentheses. Okay, so notice that I multiply both sides by 7. And then you distribute through on the right. The left side is clearly 7y, because 7 times y is usually 7y. And then here you distribute. and you got to be good at your fraction work. So remember your fraction work here. So let's do a little side work here. 7 times 3/7, excuse me, -3/7, so -3/7. So when you multiply, you have two options here. You can divide first or multiply first. I think it's easier to divide first, because guess what? 7 divided by 7 is 1, and 1 times -3 is -3. So divide first, it's easier. Okay, so divide first, then multiply. So 1 times -3 is obviously -3. So I get, when I distribute through, I get -3x here, and then 7 times 3 is 21. Almost done. I need to get the x term and the y term on the left-hand side, and clearly the x is on the right. So I add the opposite here. So the opposite of -3x is positive 3x, and then I'm done. So I get 3x plus 7y. Notice I'm adding. Okay, so put the plus sign in the middle. All right, these cancel out because they're opposites, and you get 21. So 3 times x plus 7y equals 21. And notice that's standard form. All right, and I used integers for a, b, and c. A is 3, b is 7, and c. And in fact, let me put these in red. So a is 3, b is 7, and c is 21. Let me be even more clear. Okay, a is 3, b is 7, and c is 21. And notice that these are all integers. Okay, that's what the directions are talking about here. Transform to standard form using integers only. Okay, no fractions. Notice there's no fractions in here. Okay, and that is your skill. So let's get used to that here. Let's pause and play here a little bit. If I was in class, I would have you go to the whiteboards. But right now, since you're watching the video, pause and play. Pause the video and try it, and then check it when you're ready. All right, let's check your work. Okay, the denominator is 5, so let's multiply both sides by 5. All right, so here we go. So 5 times y on the left equals, all right, 5. Let me color code things better here. 5 times y on the left equals 5 times the entire right side, which means you got to distribute through the 5. Okay, and do a little side work. So here we go. So we got 5y on the left, that's easy. 5 times 2/5. So 5 times 2/5. These divide first, it's easier. 5 divided by 5 is 1, and then 1 times 2 is 2. Or you could think of it this way, 5 times 2/5. Well, isn't that 10/5? And that's 2. So there's two ways you can do it. You can divide first, or you can multiply first. Why? Because that's how you multiply fractions, right? So there's two ways to do it. Okay, dividing first here. Okay, here we multiplied first. Either way, you're going to get 2 either way, right? Okay, so when you distribute through, 5 times 2/5 is 2, times x is 2x, and then 5 times a minus 2 is a minus 10, right? Because 5 times -2 is -10. Now the only thing you need to do is get the x term on the left-hand side. So add the opposite. Okay, and I get -2x plus 5y. You write the x term first. So -2 plus, I said add the opposite, plus 5y, all right, is equal to -10. And there you go. So -2x plus 5y equals 10. And here's A, and there's B, and here's C. There you go. Notice that they're all integers. -2, 5, and 10 are called integers. No fractions. So A equals -2, B equals 5, and C equals 10. All integers, as per the directions. Okay? So I did a little side work to help you explain the fractional work, and then I explain the result, indicating that, yeah, it's in standard form because the variables are on the left. The constant, constant is a non-variable term, okay, it doesn't include a variable, is on the right. All right, once again, pause and play and try C. Okay, so now let's check your work. There's a couple ways to do this one. Okay, one way is to distribute through the negative 1/3 first. That is one way. You don't have to do it that way. You could multiply by the reciprocal first. Might even be easier that way, but it's okay. So you get y minus 2 is equal to negative 1/3 times x. Let's do a little side work here. I got to take negative 1/3 times 6. That's negative 6 divided by 3, or negative 2. Or if you want to do it this way, you can divide first, and you get 2, and 2 times negative 1 is still negative 2. So you get negative 2 there. So write down a minus 2. Now at this point, we got to clear the fractions. So we got to multiply everything by 3, both sides. So 3 multiply by 3 on the left, multiply by 3 on the right. Notice that I multiplied both sides by 3. Distributing through, you get 3y minus 6. All right, obviously distributing through, you got to distribute twice. And distribute twice this way. Negative 1/3 times 3. Negative 1/3 times 3 is negative 3/3, or negative 1. So you're distributing through, you get negative x here. Negative 1x is negative x. And negative 2 times 3 is negative 6. Okay, now at this point, you want to get the constants on the right. So let's add 6. So I get 3y is equal to negative x, because these all cancel here. Those cancel, those cancel. And then I got to get the x on the left-hand side because the variables are on the left. Okay, so I add the opposite and I'm done. So add x on both sides, and I get x plus 3y equals 0. So x plus 3y equals 0, where a is 1, b is 3, and c is 0. A is 1, there's a 1 there. All right. B equals 3 and C equals 0. Yes, C can be 0. That's okay. All right? All right. Okay. One more time. Pause and play. All right. Pause the video and show how to express this equation in standard form 2 different ways. First, by distributing the fraction through, and then simply the next one just by clearing the fraction first. Okay. Go for it. All right, so on this one here, we're going to distribute fraction first. So y is equal to 1/4 x plus, well, 1/4 of 8 is 2. Okay, 1/4 times 8 is 8/4, or 2. Or you can do this. 8 divided by 4 is 2. And then multiply both sides by 4, because that's the denominator. Notice in red, I multiply both sides by 4. I get 4y equals, 4 times the 4th is 1. 1 times x is x. And then 4 times 2, well, it's 8. And then I add the opposite to both sides, and I get negative x plus 4y equals 8. And I'm done. Now, what you could do is you could clear the fractions first. And you do that by multiplying by the denominator. So you multiply by 4 on both sides. So here and here. Notice that I did on both sides. And you could put it right next to the 1/4 if you wanted to. That's fine too. It might even be easier for you to see. So if you want to write it like this, 4y equals 4 times the 1/4 times x plus 8. Notice that I multiplied both sides by 4 there. I just put it on the left side instead of the right side. That might be better for you to see. just because a fourth times 4 is 1, and there you go, you clear the fractions. So all you get is 4y equals x plus 8. The 1, you don't need the 1 anymore, the parentheses, so you just drop the paren there, because now the coefficient is 1, and 1 doesn't affect anything. Right? And you add the opposite again, just like I did earlier on the other side, right here, okay? And then you get negative x plus 4y equals 8. So it's the same thing done two slightly different ways. All right? You get the same result. All right, getting good. All right, let's trying all different things. And remember, this is a video, so what you could do is, if you need to, you can listen to it again and practice. That's what it's all about. All right, just listen to it as many times as you need to in order to understand it fully. Otherwise, you'll never be able to do your homework. Okay, and the last thing we need to do is graph horizontal and vertical lines. So horizontal, go left, right, vertical, go up and down. And you learn how to do it by using points. And then I will, assuming my graphing program works, I will show you how to do it using a graphing program. Let's see here. Yeah, okay, here we go. So I could do it up here with the graphing program. So I'll verify everything with the graphing program. Okay, so here we go. 2 points, determine a line. That's the key idea. So remember that. You need 2 points to draw a line. All right, at least. So when you graph a line that looks like x equals 4, notice that there's no y variable. Okay, if you're going to write it in standard form, which is, ax plus by equals c, notice that there's no y term there. So what do you think b has to be if there's no y term? If it's gone, disappeared. What does b, the coefficient, have to be to cancel this baby out? And if you're thinking 0, you got it. So here, we have x equals 4. So x, all right, plus 0y, okay, because b has to be 0 if there's no y term here, is simply equal to 4. And this is in standard form. So basically, you could substitute any value for y and get x equals 4, because we know that anything times 0 is 0. This implies that y could be anything and x will always be 4. Okay, let me write that down. So this implies that y, all right, can be any number. All right, and x is always equal to 4. X is always equal to 4. Because you can substitute anything in for y and then multiply by 0, it's still 0, and x is always equal to 4. So what I usually say is, okay, pick a value for y and x is 4. So my first order pair could be 4 comma 1, let's say, all right? Because x is always 4. Y could be any value. So 4 comma 1, 4 comma 0, 4 comma negative 3. Y could be any number. Y could be any numbers. And notice that I chose any value for y, but x is always 4. Let's write that down over here. Okay? X is always 4. So 4 comma 1, 4 comma 5, 4 comma 7. All you need is 2 points. All right? So what you do is you pick 2 points where y can be anything, x is always 4, because guess what? That's what it says up here, x is always 4. And then you plot them. So plot the points. And then check it out. So let's plot 4 comma 1. So go right 4 up 1. And then go right 4. And then go right 4, all right, down 3. So right 4, down 3. And guess what? They all line up vertically. So draw your line. There we go. So it is a vertical line. So x equals 4 is vertical. X equals 4 is a vertical line. And let me verify that for you. Let me go to a graphing program that I use in all classes from Algebra 1 through Calculus. So let's type something in. Let me get a keyboard here. So Let's type in x equals 4. There we go. And now, I need to press the go button here. That's the enter button. And notice, look right here. It's in the purple line here. So you got, you notice that the goes through the x-axis at 4. It's vertical, up and down. All right, because y can be anything, and while x is always equal to 4. So you can go 4 units to the right and up and down any distance. Okay, so when you have x equals a constant here, then it's always a vertical line. Oh, by the way, so let me illustrate it with one more thing here. So let's say if I change the 4 to a 3, watch, it still is vertical. So let me just change it. So let me put a 3 in there. Look at this. And then I go to the graph. Look at that. It's a vertical line through 3, because y, you go 3 units to the right and then go up and down any distance. Y could be anything while x is always 3. So if that was negative, let's make it negative just for funsies here. Okay, so let's put a minus sign. Minus, minus, minus. There we go. All right. Look at that. It goes through negative 3. So it's just a vertical line going through whatever number this is. All right. Now let's plot and investigate another one here. Okay, so here y equals negative 3. What does that look like? All right, so here in this case, let's go to standard form. So standard form would be, let me see, there's no x term, so a has got to be 0. So 0x, because there's no x term, right? So the coefficient has to be 0. All right, plus y equals negative 3. There's your standard form of this line. And notice that the slope is 0. What kind of lines have slope equals 0? What kind of lines have a slope equals 0, if you remember, from previous lessons? Like lesson 5.1, okay? Let me see. Let's go to this lesson here. This is what we did a long time ago. What kind of lines have a slope of 0? Oh my gosh, horizontal lines, because they have no rise, 0 rise. Okay, and so let's go back to our lesson here. So we know this is going to be horizontal, all right, but let's verify that. So we're going to, x here can be anything. So the reason why is because any number times 0 is 0, and then y is always negative 3. So x can be any number. Okay, y is always equal to 3. Always negative 3. All right, so pick any value for x. So how about 0, and then y is negative 3. X can be 1, but y is always negative 3. X can be 5, but y is always negative 3. And then let's plot these babies. Okay, plot points. And let's see if they line up horizontally. So 0, negative 3 is down here. And this means right 1, down 3. So right 1, down 3. Oh my God, they're lining up horizontally. Okay, and then this means right 5, down 3. So right 5, down 3, it'd be right here. And then take your straight edge out, okay, as we always do, and graph your line. Guess what? It is horizontal. Okay, at y equals negative 3. So when you don't see an x variable, it's horizontal. If you don't see a y variable, it is vertical. Okay, it's a little counterintuitive. The most common mistake people think is that, oh, the y-axis goes up and down, so this one's vertical. No, 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 no. Everybody say no, 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 no. Okay, you simply plot a few points and verify it. When in doubt, plot some points. So on this one here, x is always negative 2. All right, so, and then let y be anything, like 0. X is always negative 2, so let y equal, let's say, 1. All right, and then plot. This is simple as it gets. So negative 2 comma 0 is right here. Negative 2 comma 1 is right here, and notice it's vertical. So this is a vertical line right there. So it's vertical. X equals negative 2 is a vertical line. All right. Here on the next one here, y is always 2. So pick any value you want for x, like -1. Y is always 2. Pick an x value of 0. Y is always 2. Pick an x value of 3, and then plot the points. And you do this, and it'll tell you where the line is. All right. So -1, 2 is left 1, up 2. So you go left 1, up 2. 0, 2 is a y-intercept. 3, 2 is right 3, up 2. So you go right 3, up 2. And guess what? They all lie horizontally. So this is horizontal, and this is vertical. So take your straight edge out and draw your last line. So that's horizontal at y = 2. Okay? And that's all you do is pick a few points and graph. You need at least 2 points. I say at least because the fewest number is 2. So at least 2 points to graph. All right, so when in doubt, which you'll forget this later on, you pick a couple points to graph the line. And like y = 2, let me change the variables here. So y = 2, let's change this completely. And I'll verify it. So y = 2. Notice this horizontal. And it was back here in the notes too. So right here is a horizontal line through 2. Here, the graphing program also verifies what I'm saying. It's a horizontal line at 2. Y can be anything. You can go left and right any distance, but you always go up 2. Okay. Yeah, so again, this is a big lesson here. So if you need to go back and review anything, well, you can, right? Because this is a video. And my name is Mr. Ainsworth. I'm your teacher this year, trying to help you out in Algebra 1 here on standard form, which corresponds to your textbook in section 5.5. So do your homework now. All right, go to page 322 to 326. Try these problems, do them in your spiral here, and make yourself proud. And once again, you can review anything if you need to, because this is a new technology, right? It's a video. So do your best, make yourself proud, do your homework, and I'll see you in my next lesson. Bye-bye.